Okay, well here we have a system of linear equations and we're really not knowing what we're starting with. We have one equation that's in slope-intercept form, and example 2 in the textbook actually says why don't we compare the slope of both of these lines. So the m. And well, you can probably see right now that we have one equation in slope-intercept form, and so m is 2. But we have no clue what's going on with this one until we put it into slope-intercept form. So there's a couple moves that we can make. We can actually rewrite that equation as plus 1, and that is the same as negative 2 times x. Well, we still have to move over this 1, so we can subtract 1 from both sides and rewrite our equation. Negative y, or negative 1 times y, is the same as negative 2 times x minus 1. At that point, we really still don't know what the slope is because it's not in slope-intercept form. We got to deal with that negative sign. And the way we can deal with that is to divide by a negative 1. And just think about this for a sec, is that there is a coefficient of 1 in this variable. And if we were to take a negative 1 and divide it by a negative 1, that's the same thing as a positive 1. Okay, so we can actually, by dividing by a negative 1, we can rewrite this equation with a positive variable. So things are getting a little messy here, so let's kind of get it all cleaned up real fast right here. And let's rewrite this equation. We'll go ahead and divide this side by a negative 1. So when we divide on one side of the equation, we need to divide every term over here. I just want you to look at that. A negative 1 into a negative 2 is a positive 2. So we got this y, and now things are starting to look a little better. Y equals 2 times x, and this is a positive 1. So here's the second equation once we put it into slope-intercept form. Quite a few moves. Not exactly the cleanest way to do this, but now you can see that basically we have two equations that are exactly the same. And because they're exactly the same, every point on that line is a solution. Every single point. So let's just take a look. I guess we could graph this if we wanted. And I'll just say that there's my y-intercept is at plus 1. Again, remember our y-intercept is on the y-axis. That's where the line's going to cross. And then our slope is plus 2. So I'm going to rise 2. I'm going to go up 2 and move to the right 1 just to get a second point. And there's my second point right there. And then I'll draw a line as straight as I can. Just kind of trying to wrap this up. And so there's one equation. And the other equation, we can use a different color, but they're going to be concurrent to one another. They're going to actually be right upon one another. And so any ordered pair that we're given that lies on this line would be true in both statements. So that is an infinitely many solutions. You can actually tell if you have infinitely many solutions if they're both the same equation. Okay? There's another way that it's going to be a little more common. I'm going to show you in just a second. Okay, so here we're looking at the two equations again, and you may be very astute and notice that why don't I just substitute in this 2x plus 1 into the y. So I want to find an ordered pair that is a solution to both equations. And ordinarily you kind of have found that you might get a point like 1 and 2, and if you were to check it, it'd be true. But again, these special cases, like in example 1, we didn't have an ordered pair. They were parallel lines. Well, now let's take a look at what happens here. So I'm using substitution, so you're kind of working along, and then you have a something that happens like this. I'm going to substitute 2x plus 1 in for the y, and notice that minus 1, and get plus 1 is the same as 0. Okay, so that minus sign I just brought straight down, and y is right here. Okay, and we're going to use which property of multiplication? You've got it. Use a property of distributive property. I'm going to distribute that negative 1 and rewrite the whole equation and start solving this thing. So I get a minus 2x and a minus 1 plus 1. So let's see what happens. A 2x minus 2x is 0. Negative 1 plus 1 is 0. And is 0 equal to 0? Show is. 0 equals 0. Is that a true statement? Sure. So say you're solving an equation or a system and you find out a true statement. Your x and y values kind of disappeared. Then you have a special case where any point that lies on that line is going to be true. So this is infinitely many solutions. And that's how you write it on your homework. You just say infinitely many solutions. All right, hope you have fun with that.